Hello, Evergreen. We're going to do Chapter 1 Summary and Review. So just remember that this is all based on Euclid's geometry from 300 BC. See, he was one of the first geometry teachers that we can all be looking, up to and learning from. So that will be the basis of our geometry all year. Okay, going over some terms. We know that points are 1 point, and they are named point M, or whatever point they are. A line continues in both directions. That's why it has an arrow forever, or for a very long time, right? And the way you name it is you name it by the two endpoints. So this would be line MP. A line segment stops. It has a specific length. And so this is line segment AB. And then a ray is kind of a combination of a line and a line segment. So it has an endpoint on one side, and then it continues in the other direction, forever. And it can go in any direction. It doesn't only have to be pointing to the right. And you name it ray, Z, Y, or whatever the points are, the endpoint, and then a point towards the end of the ray. Collinear points. So these are points that all lie on the same line, whether they are close together or very far apart, or form a ray, a line segment, or a line. It doesn't matter. If they are on the same line, they are called collinear points. And the parts of that word are co, and that means together, and then linear means line. Non-collinear points do not make a line, even if they are connected by line segments. If they are not on the same straight line, they are not collinear. Okay, we know what a plane is. And collinear points are on that plane, so coplanar points. So they're on the same plane. Collinear points are on the same line. And then we have concurrent lines, which cross at a point of concurrency. So this could be many lines, and they're all passing through one single point. So this is a point of concurrency. Okay. We also need to talk about the types of angles. So we have a 0-degree angle. We have an acute angle, which is less than 90 degrees. We have our 90-degree angle, which is a right angle. Obtuse is greater than 190. Greater than 90 degrees, but less than 180 degrees. Because a straight angle is at 180 degrees. And then once it gets past 180 and it starts going around, can you imagine the hands of a clock going around? They are reflexive angles. And then we have a full rotation angle if it goes fully all the way around, and it is 360 degrees. And then there are no more degrees to be had, because you can imagine the hands of a clock as the two rays of our angle, and it can only go at the max of one circle, and so that would be 360 degrees. And the least it could be is 0, so we have anywhere from 0 to 360 degrees. We have opposite angles, A and B. We have complementary angles, which are two angles that add to 90 degrees exactly. We have adjacent angles, which are next to each other. And then we have supplementary angles, which are angles that add to 180. The main things to pay attention to this bottom row are complementary, which is equal to 90 degrees, and supplementary, which are equal to 180 degrees. Okay, this is a blurry picture, but we just wanted to go over a vertex is the center or connecting point of your two rays. And whenever you're using a protractor, you would line your vertex up with the center point of your protractor. You would line up the baseline or the bottom ray with the 0 baseline on your protractor. And then you need to be careful that you are using the correct top or bottom numbers depending on where you're starting. So here, since we're starting on the right side of our protractor, we will use the top row of numbers going from 0, 10, 20, 30, 40. And this is exactly 45 degrees. So we use the top scale. Okay, a polygon is a plane figure that closes in a space using only line segments. So polygons are straight lines connected to make a shape. It's kind of like a layman's terms or a layman's definitions, but they are made with straight lines. That's the main thing about a polygon, and they are closed. Here's some basic polygons. We know a triangle. A quadrilateral is a four-sided polygon. It could be a rectangle, it could be a square, it could be a rhombus, it could be a parallelogram. As long as it has four sides, it's called a quadrilateral. We have a pentagon, 5 sides, hexagon, 6, octagon, 8. Oh, and there's our parallelogram, 4. So it's also a quadrilateral. Remember, when we're measuring perimeter, we're measuring the distance around the edge of a shape, and the area is the amount of space inside of a shape. And then we're going to watch a couple videos because I think that these are really good demonstrations of how to bisect a line segment. So we would start by drawing a line segment. We'd put an endpoint of A and B. Use your protractor to measure a distance on the top and bottom. About half, just open up your protractor and connect your lines for a 90-degree angle. It'll be equally bisected. Let's watch it again. We have our line segment. Open your protractor to any measurement. Connect your lines. Bisecting a line segment. Okay, we're also going to see how to bisect an angle as well.
About how to bisect an angle. So this is the angle here that we want to bisect or cut in half. And so what you're going to want to do here is you're going to want to take the point of your compass, put it at the vertex of the angle, open up your compass, and then draw an arc such that it intersects both sides of the angle. Then we're going to use these 2 points, right here and here, to draw 2 more arcs. So I'm going to draw an arc like so. Go to the other point of intersection on the side of the angle, draw another arc like so. And now all we have to do is draw a ray through the vertex of the angle, and then this point of intersection here, and that's going to effectively bisect the angle. So let's go ahead and do that. And that's it. You can see that this angle here and this angle here are congruent.
Great. And so we also want to remember that bisecting an angle or bisecting a line segment means cutting it in half exactly. Okay, some more terms. We have a face. That means it's the flat side of a 3D shape. We have the edge, which is where 2 faces are meeting. It's the long line. It's a line segment. And then we have a vertex, which is like a point at the corner of where the edges meet. And actually, it's also the corners of the faces. So here's some basic 3D shapes and their number of faces. Like a cube has 6 faces, 12 edges, 8 vertices. And this list is here for you. You can pause the video and look at it as long as you'd like. Something interesting to note is that a sphere has 1 face. It's like a long, round, continuous face with 0 edges and 0 vertices. A cone is also interesting because it has only 2 faces. It has the one that wraps around the whole top, and then it has your bottom flat circle face. It has 1 edge, this top point, and it's also, the edge is the circular round edge, and then it has the vertice up at the top. And then you can look at the cylinder. Cylinder is also one of those strange ones that's not as easy. It has 1, 2, and then the one that goes around the sides, that's 3 faces. Edges, it has the edge of the circular face and the edge of the bottom circular face. That's 2 edges, and it has 0 vertices because it has 0 corners or points. Okay, then we have our polyhedrons, And the main thing you need to know about polyhedrons is that it is a 3D shape, but it is not made of rounded corners. So these are only made of straight edges. So they're like polygons that are 3D, so straight edges. Remember, a polygon has only straight edges that are connected, while a polyhedron is a 3D polygon. Straight edges only. Okay, and then we have our geometry nets. So a geometry net is a flattened out 3-dimensional, it shows the length, the width, and the height of a 3D figure. And so these are just some ways that you could see a 3D figure kind of folded out flat, like a 2D. So for instance, if we're looking over here at our cylinder, it has 3 faces. Remember we talked about that? And so here is an easier way if we follow this line to see those 3 faces. It has the top, the bottom, and then around the sides. Here's a cube. We can see this unfurled, and it here has 1, 2, 3, 4, 5, 6 faces. Here we have a triangular prism. If we unfold this, we have 1, 2, 3, the faces that go around, and then we have the 2 ends, the triangle and the triangle. And you can continue on and follow these lines. We have a cone with our circular base, face, and our wrapping around side. And so here's our 2 faces. And then we have our triangular triangular pyramid. So this one has 1 triangle on the bottom of this 3D shape, and then it has 3 triangles that come up to a point. These are the faces. And then here's our rectangular prism. It is similar to the cube, except we're having rectangles as the shapes that going around and squares at the ends. So this is a way to see the faces of 3D shapes. Okay, and then one of the questions on our review was how many sides of a cube or a die can you see at once? And I just wanted to kind of show you that here are some pictures of a die in different orientations, and you can typically only see how many? 3 faces at once. So here on this first die we have 1, 2, 3 faces showing. On the second one, 1, 2, 3. On the third, 1, 2, 3, and it goes on. Okay, how to draw a cube. This might come in helpful. This was something that had to do on your review as well. Let's watch this video.
How to draw a cube. So, one way I like to do it, you start off drawing a square, okay? Then from all 4 corners, you can choose whatever direction you go, but you just draw a little line. Then, from the other 3 corners, you make sure you draw another line the same direction and about the same length. Then you just connect the 4 lines to make another square, and there you have a cube.
Awesome. Okay, and then one of the problems on our review has us drawing a 30 or looking at a 30-degree triangle with one of the corners being 30 degrees. And so I wanted us to remember how to draw a 30-degree angle if you had to. So this is a great description. So we start off with a line. Use a straight edge for that. You can name your endpoints A and B. You're going to line up the center of your protractor with the vertex of your ray. You're going to use the scale to find 70 degrees. Draw a point on the outside of your protractor. You're going to connect your vertex to extend it and match this point to make it a 70 degree angle. You may name this point C, and you draw 70 degrees in the center of this angle to show the measurement, and this would be labeled angle CAB, with A being the center of your name because it is the center of your vertex. Okay. Also, let's just practice again with constructing a 120 degree. So let's do an obtuse angle as well, just to review. So we'll start off with a straight line. We'll label it A and B. We'll line up a center of our protractor with the end point of A. We're going to look at our scale and find 120 degrees. We're going to go past 90 because it is obtuse. We'll mark that on the outside edge of the protractor. We'll connect our vertex to that point. We can label this also C. And this is angle CAB, and it is 120 degrees. Awesome. Okay, and then I was wanting to end our time with a video. This is just kind of a silly, fun song, but it talks about a lot of geometry terms and how to use the protractor. So we're going to end our chapter 1 summary with a fun song, and enjoy.
Because my boys call me the degrees extractor. I build a center point, aka the origin, line it up with the vertex like a reflex. I align one ray on the baseline and measure at the other ray's tick line. In degrees, the angle measured 32. I said, dang angle, dude, you'll catch the clue. When measuring angles, remember the sign with degrees. A little circle up and to the right if you please. Protractor in my pocket, angles, degrees is my pursuit. I can measure any angle with precision absolute. Take that protractor in my hand, it's my favorite device. It's my degrees extractor, and I measure so precise. I saw an angle on the block while I was sipping my juice, and I said to my friend, man, that thing looks obtuse. I found the center point, aka the origin, line it up with the vertex like a reflex. I aligned one ray on the baseline and measured at the other ray's tick line. The measure of the angle we both could see was exactly 99 degrees, clear as could be. And then my friend said, yo, that's obtuse all right. 9 degrees less than that thing would have been right. We high-fived, followed by our secret handshake. Our love of protractors is a bond that no one can break. Protractor in my pocket, angles, degrees is my pursuit. I can measure any angle with precision absolute. Take that protractor in my hand, it's my favorite device. It's my degrees extractor, and I measure so precise. 1. A protractor can help us create angles too. It takes just a few steps. Here's what to do. First thing is to draw a straight line. Make sure the baseline and center point align. Then mark the measure we wish to find and connect it to the vertex we've designed. Now let's estimate the angle that's in sight. Is it acute? Is it obtuse? Or is it right? This angle looks greater than 90 degrees, so it's obtuse, which helps us choose the right scale to use. We'll line up one ray along the bottom line, then line up the origin with the vertex inside. Finally, we'll find the number where the other ray leads. That's the angle's measure in degrees.
Okay, guys. Well, it was a great chapter review. If you have any questions, talk to me in class or send me an email, but hope you'll have a great day. Bye.